Welcome back, everybody. We are continuing our 6.1, 6.2 graphing notes. And today we're going to add to our knowledge of exponential growth and decay by talking about the natural base e. So we have special numbers such as pi, 3.14, that go on and on and on. And then we have I, which is the square root of -1. And another special number is the letter e. This number is called the natural base e. This number was found by taking this equation and plugging in 10 to the first, 10 to the second, 10 to the fourth, fifth, 10 to the sixth, and so on, until they found that as we moved on and on and on, it came ever so close to this number right here, 2. So we are going to use the abbreviation of 2.72 for e. We also want to note that e to the negative first is about 0.368. We'll need that for a little bit later. The graph of a natural base function is the exact same as exponential growth and decay. They still have the 0, 1, go-to point, y-intercept. They still have our asymptote at y equals 0 on both graphs. And then they still have the point here and here of 1 comma your base, which your base is e. And then this is 1 e to the negative first because we're decaying. So for natural base functions, if you have e to a positive x, this is going to be growth. That's r is positive. And e to a negative x, or r is negative, will be decay. Otherwise, the domain, the range, the end behavior, asymptote, the fact that there are no x-intercepts for the parent natural base functions, all of that stuff is exactly the same. All right, let's take a look. So this is growth because it is e to a positive x. The transformations are going to be a vertical stretch of 3 and then down 2. A vertical stretch of 3 means, again, that you multiply the y values by 3. And after we do that, we move everything down 2. So I'm again starting with our parent function. We're going to use those values that we talked about on the very first page, where e to the negative first, we're going to estimate it as 0.368. E to the 0, anything to the 0 is 1. And then e to the first, we said we would estimate at 2.72. So now we're going to multiply the y values by 3 and then shove the whole graph down 2. I know if I went down 2 that my asymptote traveled down 2 from 0, and that my new asymptote is going to be y is equal to -2. So if I multiply 0.3 by 3, and then move it down 2, so that's basically 0.9 down 2, I'm going to be right around here. 1 times 3 is 3, down 2 brings us back to 0, 1. And then 2.72 times 3 is 6 point something, 7 point something. And then down 2 brings us back right around right here. So we're going to say 7 point something. And so this is going to be my graph. Is there an x-intercept? There is, but it's a decimal. So we're just going to acknowledge that by saying between -1 and 0. Our y-intercept is 0, 1 still. Our domain is still -infinity to infinity. And remember your range, we have to look at our asymptote and see where our graph is going. So our asymptote is at -2, and the graph is going up. So y is greater than -2. Our end behavior over on -infinity on the left, it's which is -2, so that's going to go in there. And then on the right side, the positive infinity, our graph is going up, so that's positive infinity. All right, letter B. This is going to be decay because e is to a -1/2 x, so that negative makes it decay. This has a y-axis reflection and a horizontal stretch. We're not going to worry too much about the horizontal stretches. So I'm going to stop with that on this one. And let's go ahead and do letter C. Growth or decay. Well, this is decay because again, it's e to the -x. Our transformations are a vertical stretch of 4 and then up 3. So for tomorrow, please finish C. Thank you so much, everybody. Hope you have a great night.